Okay, so we're going to find z-scores, quartiles, and we're going to learn how to construct a box plot of our data, also called a box and whisker plot. So the first thing we're going to do is find out the z-scores. Now, again, we're not going to calculate the z-scores for both sets of data, all of both sets of data, since there are 20 points. We'll just do a few of them. So for the city, we found that in the last video, we found that the mean was 21.7, and the standard deviation was 4.69. The equivalent numbers for highway uh, 29.8. And for the standard deviation was 5.20. Okay, so the z-scores, the formula, again, for z-score is a data point, for the z-score of a data point is that data point minus the mean over the standard deviation. So perhaps we'll just do the first couple, one, and the last couple. So for the city, let's start with the lowest data point. So call it 1 for the lowest point. So, which happens to be 15. So 15 minus 21.7 over 4.69. So we get that as negative 1.43. So we say that that 15 miles per gallon is 1.43 standard deviations below the mean. Now, it's not really, really low. But, I mean, it's substantially low, but it's not really considered an outlier. Negative 1.43, maybe moderate to high, moderate amount below the mean. If we get something that's very close, so the 21, something that's very close to the mean of our data, you can see what's going to happen here. It's going to be close to 0. And close to 0 is an indication that we are around the average. So we have negative 0.7 divided by 4.69, and we get negative 0.15. So that's a score that is very, very close to the mean, very slightly under. And finally, let's do the highest data point. So we have, again, 29. So 29 minus 21.7, the whole thing divided by 4.69, and plus 1.55. You don't really need to put a plus. I know numbers are positive unless you have a negative sign, but it's good to indicate that that's above the mean. So 1.56, again, substantially higher than the mean. Not really enough to be considered an outlier. So it doesn't look like we have any outliers in the city miles per gallon. Let's look at the highway then. So let's find the z-score again at the lowest data point. I'm going to put 23. The z-score of the number 23. So we have 23 minus 29.8 over 5.2. which gives us negative 1.31. That 40 miles per gallon, let's see, the highest data point. 40 minus 29.8, this might just be an outlier. Let's see, we have 40 minus 29.8. Divide by 5.2. Oh, very close. Very, very close. 1.96. So anything substantially, or actually anything above 40 at all, might be considered an outlier in this data set. So again, generally between, if you're looking at outliers, outliers of normally distributed data will have z-scores say the absolute value greater than 2. So it's going to be 2 or more, or negative 2 or less. Okay, so now let's get to the quartiles, interquartile range, upper lower limit. So we talk about range of a data set not being a very good measure of spread because it's so vulnerable to outliers. What we're going to see here is a modified version of that is very resistant to outliers, and that's the interquartile range. But the first things first, we got to find the quartiles. So let's make a copy of this thing here. Just we don't have to keep scrolling up. Okay, so the first thing we need to find for city, the first thing we're going to find is the second quartile, because the second quartile is the exact same thing as the median. 50% of the data, more or less, is below 50% is high. Your quartile, if your data is not, the number of data points is not an exact multiple of 4, you're not going to be able to divide your data set into exactly 4 equal pieces. That's why I say more or less. Right? But the median, if we find the median, let's see, the median, let's try to find the median of the data. So we got 15, 16, 18, 20, 21. Well, we have 10 data points, right? And so we have 5 and 5. So the second quartile, or the median, is going to be the average of 21 and 21, or just 21. Now, the first quartile is going to be the median of the first half. And the third quartile is median of second half. So if we take this first half of our data, we see the median there is 18, and the median of the second half of our data is 25. And of course we have a minimum data point of 15 and a maximum of 29. So we have here what we call our 5-number summary. That's the minimum, first quartile, second quartile, third quartile, and maximum. Now we can find the interquartile range. So the interquartile range, instead of taking the range of the entire data set, what we're going to do is we're going to take the range of just the middle quadrant. So in other words, it's going to be the third quartile minus the first quartile, and that's going to be 25 minus 18, which is going to give us 7. So this is an outlier-resistant measure of spread. So in this case, an unusual data point or outlier will be denoted not by 2 standard deviations above or below the mean, because this could be very skewed data. So what we're going to do is we're going to define the upper limit as the third quartile plus 1.5 times the interquartile range. So it's going to be 25 plus 1.5 times 7. So we're going to get 35.5. And the lower limit is going to be 18. Oh, I didn't define it yet. Let's do that. The lower limit we define as the first quartile minus 1.5 times interquartile range. So it's going to be 18 minus 1.5 times 7. And that's going to be 7.5. So any numbers outside of 35.5, of 7.5 to 35.5, which it doesn't look like we have, would be considered outliers. Okay, so why don't you pause the video for a few minutes and try the same thing with the highway data, highway miles per gallon. Okay, so let's find the median. We have, again, the average of 28 and 30. So the median is going to be 29. The first quartile, for the first half, we see the median of those first 5 data points is 26. The median of the second half of the data points is 33. And of course, the min and max, so we have the 5-number summary. In this case, is going to be the minimum, so we got 23, 26, the median 29, third quartile 33, and the upper data point 40. The interquartile range is going to be the third quartile minus the first, so it's going to be 33 minus 26, so again it's going to be 7, and so the lower limit is going to be 26 minus 1.5 times 7, and the upper limit is going to be 33 plus 1.5 times 7. So it's going to be 15.5. And 1.5 times 7, that's going to be 10.5, so 43.5. So again, it doesn't look like we have any outliers here. The 40 comes pretty close, but not quite. So the last thing we're going to do here is build our box plots. And we're going to build the box plot from the 5-number summary. So what I'm going to do, let's see, we have roughly, what is our range? We have 15 to, let's do this for both data sets combined. So let's do 15, I mean the scale for both combined. So we have 15, the 40, 20, 25, 30, 35, 40. It's nice to make a number line just to kind of, make sure we have the same scale for both of them. That everything is to scale. Right? So we'll put the city data point on top and the highway data points on the bottom. So the city data point. So our middle 3 numbers, our box, is going to be formed by the 18, 21, and 25. So there's 18, roughly, 21, and 25. And the min and max are 15 and 29. Now, for the highway data, the mid 3, the inner 3 quartiles here, 26, 29, and 33. This is highway. This is city. And then we go up to 40 and down to 23. About there. And those are our box plots. So we can certainly see the highway miles per gallon is definitely higher than the city miles per gallon. We kind of expected that. And we can see the shape. We can see that maybe the highway has a slight right skew, maybe a slight right skew for the city. It looks like they're more or less symmetric, except, like I said, maybe a slight right skew. I put question mark because sometimes there are shades of gray here. You look, definitely this whisker on the right is longer than the whisker on the left. But the right half of the box is only slightly longer than the left half of the box. So we can see the median. That's another way we could do this. Compare the mean versus median. It's right skewed if the mean is substantially higher than the median. So we can do a quick comparison. So the median is, well, that's the 29 we found. And the mean for the highway data, it was 29.8. So, yeah, very, very slight. I don't know if that's enough to formally conclude there's a right skew, particularly with our limited sample size. But that's just one of many uses you can make from 5-number summaries and box plots. Thank you for watching.